Now I know the earth is flat cause I've studied all the science. And now I know more than all the scientists. Flat earth, Steve, I got degrees in flat earth. Flat earth, Steve, I got degrees in flat earth. Hey there, it's Steve from Belize, Cuyahoga County. Now I want to go over solar eclipses and lunar eclipses on the flat earth model and show you guys how that works, how we can predict them, and even show you how they're caused. I was recently watching a flat earth debate where someone said that they don't know what a solar eclipse is and they don't know what a lunar eclipse is. And in my opinion, I don't think that's acceptable because science and math is how we know the earth is flat, and we're in 2024, so we have quantified flat earth models that allow us to make accurate astronomical predictions. So I hope I can help teach people how this stuff works and go over the basics of it. So as you know, throughout the day, the sun and moon will travel in circular paths above us. This is well known. I think we can all agree on that. There's nothing weird about that. Now, eclipses happen about every 18 years and 11 days. There's roughly there's an exact number, and these are cycles that geocentric cosmologists have known about and been tracking long before the advent of the heliocentric model. This goes back to ancient times. They're called the Saros Cycles, and I want to talk about the October 2nd eclipse that is coming up. You can see it is predicted here in the Saros 144 cycle. October 2nd, we know there's going to be an eclipse. Now, we don't know the timing of it. So I want to be very clear about that. We don't want to misrepresent anything. The Saros cycles will tell you the date, but they won't tell you the exact timing. To get the timing and the path of totality, you need to have an actual quantified flat earth model. So this is more advanced than what the ancient Babylonians were doing. The sorcerers could still give you the date, but they didn't have computers like we do now, where I'm going to show you how the flat earth model can actually predict the exact timing. So let's take a look at the orbits of the sun and moon. And right now it's September 24th. We don't have that many days until October 2nd. So let's just cycle through the days and see what happens to the orbits of the sun and moon. So are they intersecting? That looks like what it will happen. And then we also see that we have a new moon, which is the solid black phase. Now, let's go through the timing and see when these orbits will intersect with each other. So let me actually zoom up here so you can actually try to see what I'm trying to do. So see how they're almost touching? I believe there will be a moment where they are like touching, intersecting. And when that happens, I believe that is when the solar eclipse will happen. So let me just now zoom out. Yeah, perfect. So you see right here, we predicted the solar eclipse. For me in Belize at Central Time, I can expect to look up at about 10 o'clock a.m. and see this solar eclipse. So I'm going to test that when it actually comes, because for me it's all about the science and math. I want to be able to, like, I made this model, so I want to be able to test it to confirm that it's accurate, and if it's not, I want to know what I did wrong. So for me, I implemented these Saros cycles. You can look them up. They're very basic. It's every 18 years, and this is well tested. We know it's going to work. Now, what I did is I implemented the flat Earth celestial mechanics, where we get that intersection of lunar nodes. So let me just show you what I'm talking about. See right here, even in Eastern cosmology, so you see the Rahu at the top and Ketu at the bottom, they knew that when these two paths intersect, we're going to have either a lunar or a solar eclipse. It happens every 18 years. You can't argue about it. So with Rahu, they said that Rahu was this solid black object that crosses in front of the sun, and that is exactly what we see on the flat Earth model. We see, oh, are they actually moving? Oh, that's cool. But we see that the solid black object crosses in front of the sun, and we get a solar eclipse. You can look online for photos of a solar eclipse, and this will be it. Now, if the black object was completely covering the sun, you'll have a little ring, because you know the sun has a glow. So even though they are the exact same size, the sun and moon are the exact same size, you'll still have that outer ring glow around it. So I think that's really, really cool. One other thing. So let's talk about a lunar eclipse. So for a lunar eclipse to happen, we know that we're going to have a full moon, and we know that the sun and the moon are going to be on opposite sides. Now, from my memory, I think there's one around March 15th in 2025. So let's go there and just see what these orbits look like. Close. So see how we have the full moon and it's on opposite sides, but what I need is to know when these orbits intersect. That is how in flat Earth celestial mechanics, well actually all, like there's only one cosmology, so just in science in general, this is how we determine when there is an eclipse. So let's keep on going through the days. No. So the orbit's getting larger. See that? So we want to subtract days. So it might not be March 15th, it might be March 14th or the 12th. Let's see as we go. Okay, no. So it's going to be right around here. And then let's play with the time. So it gets bigger that way and smaller this way. Okay, cool. So then let's, yeah, hold on. Let's try to get that perfect intersection. Oh yeah, the scientific method's been applied. So then if we zoom out, I can guarantee you that the sun will be on the exact opposite side. So see that? Let's go to a bird's eye view just so it looks a little cleaner. Now, what happens with a lunar eclipse is we need the sun to somehow intersect with the moon, but they're on opposite sides right now of the Earth. So how does that happen? You'll want to look into what's called the coffee cup caustic. What this does is it causes the sun to focus its beam right over here on the moon. Now, I'm probably going to throw a photo up here when I go to edit this video just so you can actually see what the coffee cup caustic is. And then I'm also going to put a little photo for the solar eclipse maybe 5 minutes back, just because I want you guys to really understand what these look like and how the flat Earth model confirms that lunar eclipses and solar eclipses are real, they do happen, and the flat Earth model is a testament to that.